I'm in front here of the Lucas Nulle Servo machine test system, and I would like to speak about drive technology. Drive technology is one of the most interesting but also very challenging topic in training young people. At first, I'd like to introduce the servo machine test system. The system consists of the control unit, this is this panel here, and then the brake itself, the black unit here. On the other hand side, we have our machine under test, that orange unit. This orange asynchronous motor is connected to the grid via a star delta switch. At the first step, I like to combine the motor and the brake system. So you need no tools, it's very easy to combine both systems. Then I fix it with the screw, and then we have here a shaft cover which fits exactly between motor and test system. You can see here the green light. This green light indicates that no fault is occurring at the moment. So the system itself is very safe. There are no space between the both machines. The shaft cover avoid touching the shaft. Then each motor has also a built-in temperature contact. So if the motor is too hot or become too hot, it will trip and the control unit will stop. So everything is done for the safety with the servo machine test system. In the latest version, we have also included, we call it EDD, electronic drive data. So that means every motor transmits his values via a special protocol to our unit here. That means the servo machine test system knows which kind of motor is adjusted and do all the preparings for you. So it makes it much more easier than before to do all the settings. In the next step, I will show you the ILA course which is coming with the system. The ILA course is in this way, that we start here for the asynchronous motor. On the first page, we see the training contents, the prerequisites, and so you see what is done in the course. Then you get information about the equipment. So at the first step, we have here the complete equipment list. And then for all relevant material, we have detailed description of all the things. Also, the software active servo is explained in every course. So for example, if I go to motor characteristics, we will find also small videos which shows you how to operate the system. So here we see how it works, and so you get completely guided in front of doing the experiments. What I like to show you now is to perform one or two experiments with the system. So I will move to the experiments taking the characteristic of a star delta switch. So I will move to the experiment page. Here we start again with the training contents for this special experiment. You see here in the next step the circuit diagram. So all the complete wiring, everything is done in a circuit diagram to be on the normal technical level. And in the second step, we have also a detailed picture which shows you step by step doing the assembling. For example, here the PC system, the PE connection, temperature connection, motor circuit, all the wirings are shown in this small animation. In the next step, you will get guided step by step during the experiments. That means here we see start the software active servo, select motor characters, and so step by step you get guided. So and I will do this. So in the first step I will open the software active servo. So if the software is open, the PC is connected via the USB cable to the control unit. The complete supervising is done by the PC. In the first step, I like to record characteristic of star and delta circuit. So I will start the power supply and I will switch on the motor to the star circuit with the star delta switch. To start the characteristic, I will press enable here, then I have to switch the enable, the one button here on the control unit. This is a safety feature, so the software asks to push the button here, so the students or the student know that now something happens to our machine. Say OK. Then I press the output ramp button, and now the motor gets braked step by step from the no load speed to the standstill speed. And what we see here in the characteristic in the graph, that is the characteristic for the Y circuit, for the star circuit. The next step is, I will press the enable button again, and now we switch the motor to delta connection, and then we will see how the motor behaves in delta connection. I will press the enable button again, start the system pressing the one button, going to output ramp, and then the system records the characteristic for the delta. So I will switch off the motor, software also, and what we see here is we have a big difference between the both torque. And so we see, okay, if the motor runs in Y connection, star connection, the torque would not be as high as in the delta connection. What should we do with such characteristic? For example, I like to see also what is other values given from the motor. So I make a double click here. For example, I select current, and I see, okay, that's the motor current. Then I can take this picture, say copy, and paste it to a special placeholder in our ILA course. These ILA courses are able to print out later if you have done the laboratory, and so you get all the information to take it back to home. Now we have seen one side of the medal. We have looked on the motor side, but motors in the industry are not only motors, they are applied to drive a working machine. And now we come to the working machine. For example, we have in the industry a big ventilator, and the idea is now to bring this ventilator in the laboratory. So what we did in the software or in the system, we implement the characteristic of the ventilator in our servo machine test system. So the black unit behaves now like this ventilator. So I move here, I move here to the point load simulation, and then I can arrange different load or working machines. For example, pump, ventilator, calander, hoist drive, compressors, winding machines, inertia wheel, or time-dependent load. So we have all the well-known loads in the software, and they can be used in the laboratory. Now I have adjusted the ventilator. The size of the ventilator can be changed by the value load constant. So I put a special value inside. Normally these values are given in the ILA course, so that the student has to know which is the correct value. And if I press the enable and start the system, the black unit here, our servo machine test system, will behave like the ventilator. If I start now the motor, we see the working point comes across both characteristics between ventilator and the torque line of the motor. If I move to delta, I see the behavior. normally this behavior is shown on the whiteboard, drawing all the lines, and you see you have to believe that the working point is exactly at that point. But with the hardware here we have now, you can do it in an experimental way, which helps the student to understand the interaction between the both systems. Now the question is why we use star-delta connection. Star-delta connection is used to reduce the inrush current of motors. Let's try to do one other example. I will move to another working machine like a hose drive, which could be a normal tooling machine in the industry. And if I look on the motor weight blade, I see, okay, this motor has a value for approx 0.37 kilowatt. And so the torque should be around 2 and something Newton meters. So I applied here a value of 2.2 Newton meter for the torque. And now I try to run the motor with the star-delta switch. I enable the load, press OK here, start to Y circuit or star circuit, and nothing happens. The motor couldn't start. There's no torque, not enough torque to start. We see here the working point is at this point, and no turning of the motor. If I go to delta, I see, okay, the motor is turning. So for example, for this special machine, star delta is not working. But what is happening with the current inside the system? To discover the inrush current, I will choose another load machine, working machine. I choose the inertia wheel, and then I change the flywheel to 1000 kilogram square centimeters. And now I can also adjust the axis for this. I will choose 20 seconds. For the trigger, I can choose the speed, for example. And here with this small anchors, I can select a triggering point. So now I've adjusted the flywheel with the values. But for the inrush current, it's also interesting to see the current. With a double click, I can adjust the current here. Start enable again. And press record button. What we see here is now all the values are measured. And now I can start in the next step the motor. If I start the motor in the Y, see what happens, and then I switch to delta. And I can see directly the behavior. So we start here with a small current, then with a higher current if I switch to the delta. And we see also the torque which is given by the speed up of the system. If I stop it again, press stop. The challenge now is to reduce this inrush current up to, I will say, 1.5 amperes. So the students has to find the right time, the correct value to do the switching, to understand what happens. So this knowledge can be used, transfer later for the industry to understand what happens then. So what will we do? We will do the same experiment again, press 1 again, press record again. And now I start in Y circuit. And now I have to wait until the right point is given to switch to delta connection. And now we see we have reduced this high inrush current to a small value. I will stop it here. This demonstrates you how easy it is to bring these things to the laboratory to understand what happens. So we have real life situations in the laboratory, and we have the tools to show it to visualize all these things and make it clear. That's for the students and the workers for tomorrow. They understand the behavior between motors, drives, and working machines and can transfer this knowledge to the industry later. The experiment I showed you was only a first impression of the system. So we start with an asynchronous motor, but the system can also handle DC motors, synchronous motors, AC motors. Every kind of motor can be used with the system. Or you can expand the system to a real power electronic system like frequency converter, industrial or didactical ones. So you can use it in many ways. If you have further questions, please visit our website or contact us.